Welcome to our deep dive into the world of perovskite solar cells, a groundbreaking technology that's revolutionizing solar energy. You see, traditional silicon solar panels, they're great and all, but perovskites offer a whole new level of efficiency and versatility. Join me, your trusty guide, as we explore the incredible science behind these amazing devices. We'll uncover their inner workings, discover the different types of perovskite solar cells, and understand why they hold the key to a brighter, more sustainable future. Get ready to be energized because things are about to get electrifying. Alright, science fans, let's break down the design of these revolutionary solar cells. Imagine a perfectly stacked sandwich. That's the basic idea behind perovskite solar cell architecture. First up, we've got planar heterojunction solar cells. They're like the classic sandwich, nice and simple. You've got your perovskite layer sandwiched between two different materials responsible for conducting those positive and negative charges, those electrons and holes, remember. Now, these planar cells are great because they're relatively easy to make, but they can be a bit delicate. Next, we have the mesoscopic structure. And this is where things get really interesting. Picture a more complex sandwich with layers upon layers of different materials. The perovskite in these cells forms tiny crystals, kind of like a tightly packed mosaic. This unique structure allows them to absorb more sunlight, making them super efficient. There are even different subtypes of mesoscopic cells, like those with special scaffolding to support the perovskite or those with intricate networks for better charge transport. Of course, each structure has its advantages and challenges, but that's what makes this field so exciting. Scientists are constantly tweaking and improving these designs to create the most efficient and cost-effective perovskite solar cells possible. Hold on to your lab coats, everyone, because we're about to enter the fascinating world of perovskite dimensionality. You see, these amazing materials can be engineered at different scales, kind of like building with molecular Lego bricks. First, we have the big kahuna, three-dimensional perovskites. These are the most common type and the ones we've been talking about so far. They're highly efficient at converting sunlight into electricity, but they can be a bit sensitive to moisture and heat. Next, we have two-dimensional perovskites, which are like thinner, flatter versions of their three-dimensional counterparts. Think of them as sheets of perovskite material stacked on top of each other. This unique structure makes them more stable and less prone to those pesky environmental factors. But wait, there's more. We also have quasi-two-dimensional perovskites, which are like a hybrid between two-dimensional and three-dimensional structures. They offer a great balance between efficiency and stability, making them a hot topic in perovskite research. Each dimension has its own set of advantages and challenges, and scientists are working tirelessly to unlock their full potential. It's like a thrilling race to find the perfect perovskite structure for every application imaginable. It's time to put on our chef hats and whip up some perovskite concoctions. Just like in baking, the ingredients we use in perovskite solar cells can dramatically affect their performance. Our first recipe calls for organic-inorganic hybrid perovskites. These are the most common type, combining organic and inorganic materials. Think of it like a delicious blend of fruits and nuts in a trail mix. They're relatively easy to make and offer great efficiency, but they can be a bit sensitive to moisture. Next, we have all-inorganic perovskites. As the name suggests, these bad boys are made entirely of inorganic materials like cesium, lead, and iodine. They're like the rock-solid foundation of a building, incredibly stable and resistant to harsh conditions. Finally, we have the eco-warriors of the perovskite world, lead-free perovskites. You see, lead is a toxic material, so scientists are hard at work developing lead-free alternatives. These new materials are like the superheroes of solar energy, offering both high performance and environmental friendliness. From tweaking existing recipes to discovering entirely new ones, researchers are constantly pushing the boundaries of perovskite composition. It's a delicious pursuit of the perfect blend of efficiency, stability, and sustainability. Now that we know the ingredients, let's fire up the perovskite production line. Just like building a house, creating efficient and affordable solar cells requires the right tools and techniques. One popular method is solution processing. Imagine spreading perovskite ink onto a surface, kind of like painting with light. This technique is incredibly versatile and cost-effective, making it ideal for large-scale production. On the other end of the spectrum, we have vacuum processing. This method involves depositing thin films of perovskite material in a vacuum chamber. It's a more precise and controlled process, resulting in high-quality solar cells. Each fabrication method has its own set of advantages and applications. Solution processing is like the trusty hammer, perfect for everyday tasks, while vacuum processing is more like a high-powered laser, ideal for specialized jobs. As technology advances, scientists are constantly developing new and improved fabrication techniques. From inkjet printing to three-dimensional printing, the possibilities are as limitless as the power of the sun itself. Thanks for joining us on this journey through the fascinating world of perovskite solar cells. From their unique architectures and diverse compositions to the cutting-edge fabrication techniques, these incredible devices are poised to revolutionize the way we harness the power of the sun. As research and development continue to advance, we can expect to see even more efficient, affordable and versatile perovskite solar cells hitting the market. These advancements will pave the way for a cleaner, more sustainable future, powering everything from our homes and businesses to our cars and electronic devices. Stay tuned for more insights into the future of renewable energy.